All right, as far as what we're going to do today, I'm going to go over Chapter 8 right now, which is the second look at classes and objects. Most of the stuff that I'd want to put into a program, you already have in your program. So this is just going to be more so you hear the different stuff that's in here. All right, when we get done, we're going to write that array program that I told you about. We're going to do that in just a second. After we do that, I'm going to say, now, I want you to make changes to it, and I'll explain that when you see it, okay? Tomorrow, we will go over Chapter 9. Again, you won't be tested on Chapter 9. Your next test will be next Monday, and that'll be on Chapters 6, 7, and 8. And of course, anything that's in Chapters 1 to 5 is fair game, but I'm not going to pull special stuff out of there, all right? What I thought I would do Friday, unless people have a problem with it, I guess you got your choice. We can do one of two things. On Friday, either we can actually take the test, which I don't think probably most people want to do on a Friday, or, and this is what I thought I'd do, I'll give you kind of, for lack of better words, a practice test, and I'll give you a couple hours to work on it, and then we'll go over it so you have an idea, all right? Now, you will have a little bit of time to work today. What I did with people yesterday, I don't know if you saw my email or not. Okay. I let people take their tests back, and I let them work on them. And I said, you can make changes, and you can get half your points back. So I will make the same deal for you, but I will give you there will be time at the end of the period today. All right? So again, right now we're going over Chapter 8. There's nothing in Chapter 8. So, for instance, the toString method. They show you how to overwrite toString. You've already done that. They do some better talking about what static means. I want to spend some time on that. But the methods that copy objects, that's probably amongst the hardest thing there is in the language. So we'll talk about it, but I'm not going to test you on that. All right? That's not my goal. All right? If this was a full semester, full 80-day long Java class, maybe. I don't know. All right? And tomorrow when we go over, we're going to write a program. So we're going to go over Chapter 9, which is on the wrapper methods, and then we'll write at least a program afterwards. All right. So here's our topics: static class members, passing objects as arguments to methods, returning objects from methods. You heard this shtick yesterday when we talked about arrays. I told you that if you pass an entire array into a method, you end up passing the address to the beginning of the array in. The bottom line is, if you pass an array into a method, you pass it by reference. So you don't pass a copy of it like you do with a primitive variable. You pass the address. So any changes you make are permanent changes. In much the same way, if you pass an object to a method, you pass the address of where the object resides in memory. So when you pass an object to a method in Java, you are passing it by reference. So any change you make is a permanent change. All right, if you pass the entire object. Not only can you pass an object to a method, you can return an object from a method. All right, the toString, as I mentioned, that's on writing a toString method. All right, writing an equals method, we'll get to that. But like I said, to me, this is amongst the hardest things in this entire book. All right, is this methods that copy object, because there's two ways that you can do it. And either you're going to look at it and go, oh, that makes sense, or you're going to be like, I don't have a flipping clue as to what you mean. All right. We'll also talk about aggregation, and that's when you create an object and then you create another object where the first object is part of it. All right, if you don't know what I mean, I'll give you an example when we get to that point. We talk about the this reference in more detail. Enumerated data types, which I think we've looked at a little, but we look at them again. Garbage collection, if you've never heard of that before, so we'll talk about that. And finally, we're going to talk about what are typically called CRC cards. All right? And that's class collaboration cards. And we'll get to that in just a bit. So as we start, the reason that this stuff is important is I have not written your next test yet. All right, I haven't written the practice test. I haven't written your test. I will write them both within the next couple days. And I may put in there no global variables, for example. So you do have to know how to pass stuff around. That should make sense to you by now. Hopefully the concept of an instance variable makes sense to you. So every time you create a rectangle, each rectangle will have its own length and will have its own width. That should make sense by now. All right. If I had you create an account, let's say that I had you create a bank account class. All right. Okay, it doesn't even matter. Let's say it's a checking account class, and you have to have your own. Each time you create a class, it has to have its own beginning balance. All right. So then beginning balance would be an instance variable. Does the concept of instance variable make sense to everybody? Each instance or each object has its own copies. All right, and that's what they're saying right there. So instance methods require that an instance of the class be created. All right. So you can't use the name of the class dot something. That wouldn't work. Instance methods typically react with instance fields, or they calculate values based on instance fields. All right. Hopefully, just going over that like we just did, at least it makes sense, because this is what you've been doing. If you remember, when we first got into this in Chapter 6, I created 5 payroll objects for you. I made a Jeff, a Sandy, a Taylor, a Kenzie, and a Chloe. Each one of them had their own first name, their own last name, their own hours that they worked, their own hourly rate, and their own pay, their own gross pay. Those are all instance variables. We also had a variable in there called emp count, or count, and another one called tot gross. Those were not instance variables. Those were class variables, so they were shared. They were not static. All right? I'm sorry, they were static. We're going to get into all that in just a minute. Static fields and static methods do not belong to a single instance of the class. To invoke a static method, you use the name of the class. What the author is saying right here is, guess what? You've already used these. If not in this language, in other languages. So if you look at the example they give here, it says double val equals math.square root. Math is the name of a Java class. But you don't have to create a math object in order to be able to use the sqrt method. You can say the name of the class dot the name of the method. When you do that like this, then the method has to be a static method. Did you hear that? You're going to see some examples as we go on. All right? As it says, class fields are declared static using the static keyword. Java is kind of a weird language, because I think, for example, if you say private static int instance count equals 0 like this, it works fine. I could be wrong, but I think if you even say static private, it works. I've done it already where I accidentally typed it in the wrong order, and it seems to work anyway. That said, what you should get used to doing is first, this is called the access specifier. In Java, this is public, or it's private, or it's protected. That should be first. Then if something is going to be a class variable or a class method, then the word static should come. Then the type, then the name, and if you want to, some initializing. All right? The key thing when you look at this is right underneath here. When you work with a static field, it's only initialized one time. It's supposed to retain its value. So let's say that, I don't know, I work at an insurance company, and we use a Java program, and we're using an array list. So I'm constantly adding new customers. All right? I'm constantly removing existing customers. I'm constantly changing existing customers, their address. Maybe they got married or divorced or whatever. All right? If I wanted to count every single day of how many people I added, another count of how many people I deleted, and another count of how many people I modified, those would be 3 static variables that at the top of the program I would initialize them to 0, then I would add 1 to them each time I did an add or a delete or an update. Does that make sense? I don't know any other way to say it to you other than that. Okay? I've given you this example before. I'll come right back to this slide. But again, when we talked about this, okay, and I said that length and width would both be instance variables. If every time I created a rectangle, I wanted a count of how many rectangles I made, so if I made a variable called rectangle count, that would be a static variable. Because if I made 10 different rectangles, I would want that to equal 10. If I don't make it static, it's not going to work right. All right? Now, what's confusing about this is if you look on the next page here. All right? It says here static fields. Instant count field. This is a static field. All right? And what's going to happen is when you work with a static field like this, even if you don't have these created yet, you can have the name of your class dot the name of your field. All right? So for instance, in the payroll stuff that we did, it could be like payroll dot. Instead of the name of one of the objects, it can be the name of the class. All right. Not only can you have static variables, you can have static methods. Just like we just saw with variables, if you want static methods, you need to put the word static in there. It says when a class contains a static method, it is not necessary to create an instance of the class in order to use the method. The same class can have both static methods and non-static methods, static variables and non-static variables. They can have a mix of the two, just one, just the other. All right? So you know there's a lot of different ways, permutations or combinations that you can use with this, just so you're aware of that. All right? But either way, whether it is a variable or whether it's a method, it's going to be for a variable, private static, and then the type, and then the name. For a method, it'll be public static, and the type, and the name. All right? Static methods, again, are convenient because you don't have to create an object to call them. And the math one is the one we just looked at. Static methods may not communicate with instance fields, only with static fields. That's really important. Do you remember when, before chapter 6, 7, and 8, when we first started with Java, remember how the first program we took and made everything in main? Remember that? All right. And then all of a sudden we created other methods that were called from main. And if we didn't put static in there, they didn't work because they were dealing with a static method. All right. So again, static methods may not communicate with instance variables, only with static fields. So some of those fields we had to go back and put static in there. All right. You can pass anything to a method. You can pass any one of those 8 primitive variables that we talked about the other day. So an int, a short, a long, a byte, a float, a double, a char, or a boolean. If you pass any of those 8 primitive variables, you pass those 8 primitive variables by value. This right here, that means you pass a copy. So any changes you make to something you pass by value, you make it to a copy. Once you go back to the calling method, the value's gone. But if you pass an object, it's automatically then passed by reference. So a copy of the address is passed, not a copy of the variable. That means when you think of copy by value, think of the word copy. or pass by value, think of the word copy. You're making a copy. But when you think of pass by reference, it's the real thing. So any change you make to an object that's passed in is a permanent change. All right? That's if you pass in the entire object. Okay, then it's passed in by reference. So it is a permanent change. And they're showing that here. It's no big thing one way or the other. You can also return. So notice what they're doing here. They're returning a bank account object. All right? So not only can you return, you can return nothing, where the return type's void. All right? You can return one of those 8 primitives, and that's pretty much what we've been doing thus far. But you can also return an object. And if you wanted to, you could even return an array of objects. All right? So if we said here, public static bank account, bracket, bracket right there, we don't have that. But if we did, then we would have to make sure in here we were returning an array of those objects. You can do that. And I mentioned yesterday, you can have an array of objects. You can have objects whose members are arrays. All right? So you can combine these any way you want to, need to, have to, in order to be able to get done whatever it is you want to get done. All right, the toString, we talked about this before. You've done this already. The author is saying that if you do this, if you say system.out.println and you haven't overwritten toString, you're going to get something, I thought they showed it, but I guess they don't, that just looks like garbage. You may or may not remember that. All right, it had started with an @ sign and it looked really ugly. There were a bunch of numbers and letters. That was its address basically in memory where it lived. Okay, if you want this right here, system.out.println, to be able to print XYZ, something like, I don't know, stock name, XYZ, stock value per share, 9.62, then you have to override the toString method. The toString method is a stupid method. All right, it only does what you tell it to do. When we did our earlier programs, the ones before Chapter 6, all we told it to do was print out the value of a string and or print out the value of a primitive. It doesn't work as far as printing out the value of objects. It doesn't understand. So you have to override toString to make it understand. That's exactly what they're saying right here. So you come into the toString method and you basically literally just say, public string, toString, boom. You make it do whatever it is you want it to do. All right? So if you don't do that, this is what it says you're getting. That thing with the @ sign, it's a hash. So it's an internal representation of the memory, of the address where the object lives in memory. All right. The equal method. We've talked about this before. How you, for example, you cannot say, you've seen me put this up there before, so I can't say string S1 equals Bob, string S2 equals Bob. Then if I say if S1 equal S2, that's false. We've talked about this already, and it's false because equal says for strings, do they point to the same memory location? These two don't. All right. Now, if I had done this, if I had come in here and literally written this, instead of saying string S2 equal Bob, if I'd have done this, if I'd have said string S2 equals S1, now it would be true because they do point to the same location in memory. All right? So the author says when the double equal sign is used with reference variables, all it compares are the addresses in memory to see where it lives. So if I want to grab an array or an object or something to see if it's equal, I can't do it like this. That's not going to work. Even though stock 1 and stock 2 have the same contents, all right, they're at different addresses. And if that still confuses you, look at it this way, okay? Let's I don't know where she lives, none of my business, but let's say that wherever Tiffany lives, somebody moves in right next door to her that happens to be named Tiffany Harris. And they move in there, okay? The contents are not the same. They might have the same thing inside as far as a name, but the actual contents are different. And that's the same kind of an idea that they're talking about here. All right? Again, the other day I got Jeffrey R. Scott's mail. All right. So instead of using the double equals, you should use the equals method. You write your own. Okay? So imagine I've got two objects here. I'm going to keep this real simple. We have two payroll objects. So we've got payroll P1 and we've got payroll P2. All right? And let's say they both do hold the same thing. So Jane Doe 40 25. Jane Doe 40 25. What the author is saying right there, the author is saying is if you want to do that, you have to compare these two things, and these two things, and these two things, and these two things. Does that make sense? You've got to compare each part of the object. All right? So each attribute in the object must be compared. Okay? Now, if I did this, if I had Jane here and I had John here, do I literally have to compare everything that's in there? No, because as soon as I compare these two, I know they're not the same, right? Okay, so that's what they're talking about in here. You do this, but where it says symbol.equals, okay, notice what they're doing here. They're saying, okay, does this symbol equal this symbol, and does this price equal this price? You have to find a way to compare every single thing in both objects, is what they're getting to. And then if it returns true, they both have the same information. If it returns false, they don't. All right. As I mentioned, this is the hardest part right here. It says there's two ways that you can copy an object. Okay? You can do what's called a reference copy, and sometimes this is called where it says reference only copy. All right? That just copies the address from one object to the other object. That's kind of like what we did before with this. That's kind of what this is doing. All right? But you can also do a deep copy. When you create a deep copy, notice what it says. You create a new instance of the class, and then you copy the values one at a time over. Okay? So you don't just copy the address of one into the other, because that's more or less, again, that's like an alias. All right? You instead make a new object and copy the fields over from the original to the copy. That's what they're saying here. All right? Which, again, either probably makes total sense or doesn't make any sense. I don't want to go through it any more than that because this probably would confuse you. Went back and was reading that last night, and I thought, that's enough. All right? One thing, and I think you're all, in fact, I know you're all smart enough to realize this, okay? So, it's May, okay? Valerie applies for a job. She probably thinks I'd never do this, but as a Java programmer, okay, she gets an interview. She goes through, she does the interview, she does a really good job, they ask her some stuff, they ask her to do some stuff, etc. They hire her. Do you think day one, as soon as she comes in, they're going to give her a project where they expect she knows everything that somebody who was working there 10 years knows? I don't think that's going to happen. They think that, not that you're going to fail, but that you're going to have to learn. There'll be things that your instructor didn't teach you. There'll be things your instructor didn't teach you because probably he doesn't know them. And it's hard for him to teach you stuff he doesn't know. All right, but again, now we're not even spending 40 days on Java. We're spending more like about 20 to 25. So you're getting blitzed with this stuff, okay? And once we get into the Android, we'll do Android Java, And yes, you'll use a lot of this stuff, but I think your mindset's going to change. It'll be like, now I've got to be thinking Android. All right. So creating an instance of one class as a reference in another class is object aggregation. Okay. Now I gave you an example of this in an earlier class where I said, imagine I create a clock object. And the clock object has hours, minutes, and seconds. It's got getters and setters for the hours, minutes, and seconds, etc. Now I create another class called alarm clock. All right. Well, isn't an alarm clock just a clock? It's got other things. It can set an alarm, turn on an alarm, turn off an alarm, etc. But what I could do is I could take that clock class I made and put it in as a member of my alarm clock class. And if that still confuses you, think about an automobile. All right? I mean, I could grab anything. I could grab this computer, but think about an automobile and think about what an automobile has. It has 4 tires, right? So I could create a tires class and have all sorts of stuff in there, to set the inflation rate, get the inflation, all that stuff. And then I could come in and create a car class, and I could have as one of the 4 of the members of that car class 4 tires. All right? That's what they're talking about in here. It has a relationship. When we get to chapter 10, we will talk about inheritance. Inheritance has an is-a relationship. All right? You hear that saying, he or she is a chip off the old block type of an idea? All right. Is-a, that's inheritance. Has-a, that's aggregation. So the example that they use in here, and unfortunately, we don't have this code. But when you look at it, we've got 3 classes. We've got a course class, an instructor class, and a textbooks class. All right? And each course has a name. That should make sense. But the other 2 components of the course are instructor, so that's all of this stuff, and textbook, which is all of this stuff. So in other words, we first create the instructor and the textbook classes. You have to create those first because otherwise the system wouldn't know what an instructor object and what a textbook and an instructor object are. So that's an example of what is referred to as composition or aggregation. All right. Again, this goes back to the stuff we talked about before. Avoid returning references to private data elements. Don't worry about it. Okay? Null. You remember I gave you this definition a long time ago. What does null mean? What's a one-word definition for null? One word. Unknown. Very good. Unknown. If I say, Ethan, what's your GPA right now? Because I don't have any idea. That's null. I don't want to set it up and create an Ethan object and give it a GPA of 0.0. I know it isn't that. He hasn't failed any classes with me, so it couldn't be 0.0. Null means unknown. If something is null, you can't do anything with it. All right? In fact, if I come in there and I write this, if I write int age and don't give it a value, now in the next line I write system.out.println age equals plus age. I'm going to get an error when I do that, and it'll actually be called a null pointer exception, which means that that variable right now is pointing to a value of null, and you're trying to do an operation on something that has a value of null. Okay? And again, that will be called a null pointer exception. You can look it up if you want. In fact, we're going to go and actually look up some stuff in the API in a little bit. All right, the this reference. Look on the screen if you would, please. Are we all comfortable with this right now? I shouldn't say with this, but the fact that we need to use the word this right there because someplace up here we defined an instance variable called feet, and we're also calling it feet here. So remember, in Java, if the name of your actual parameter, all right, the actual parameter, if it's a instance variable, if the name of the actual parameter is the same name as the formal parameter, then when you use it, you need to say this dot. You can always say this dot in front of anything if it's a variable. It won't hurt anything. If I had called this f right there, if that just said int f, then I could say feet equal f. But since I called it feet, and it was defined up here someplace as feet, that's why I need the word this. So as it says, this is simply a name that an object uses to refer to itself. All right, it's contextual. So the system looks at it and it says, what am I pointing to right now? What are we talking about? And that's what it equates with the word this. When you do this, this overcomes what's called shadowing. When you've got the same name here as here. You don't want to, either we have to use this, or if we did this, if we made that F right there, then we could get rid of this dot if we wanted to, and we'd say F there. All right? You can also use this in constructors. This is very confusing. All right? You don't typically do this, especially when you're first starting out. Remember what a constructor is? Everybody remember that? That when you create a new object, a constructor is what gets called automatically, right? And remember that you have what are called, you can overload constructors. So you can have a whole bunch of them as long as what's in the parens is different. If I have something I want to do every single time, regardless of the constructor, always do some operation, then I can basically do it like this, where I use the this. And I can do that in every one. All right? If that confuses you, just take a read at what's in here. It's either going to make it where like, oh, that makes sense, or it's like, I don't have a flaming clue. The idea is, especially when you're first starting, it's not something you'd probably be doing anyway.
That's where you set defaults, right?
It's if you wanted to set defaults in every one in the same way, it would be a way you could do it. All right. Okay, enumerated types we talked about. An enumerated data type is a user-defined data type. That's the simplest definition I can give you. In the example they give here, we've created a brand new data type. The name of the data type is day. What most people do, it's not mandatory that you do this, but most people, when they create an enumeration, as you see in blue up there, they take all the possible values for the enumeration and they make them all uppercase. All right? They are constants. You can't change them. Okay? Now, by default, meaning unless told otherwise, Sunday, right there, that equals 0. Monday equals 1, Tuesday equals 2, Wednesday is 3, Thursday is 4, Friday is 5, and Saturday is 6. If you don't like that, you can come in here and say Sunday equal 1. Then Monday is 2, Tuesday is 3, etc. All right? Not only that, if I came in here, let's just pretend for a second, I was coming in here and I was going to create my own enumeration. Don't ask me why I do this. Let's just say I was going to. So I came in here and I said enum, and I'm going to call it trees. All right? And I'm going to put in here oak, maple, apple, just like that. All right? And then, in fact, we'll put in cherry. We'll just leave it at that. That should be enough. So by default, the value of oak is 0. The value of maple is 1, etc. You all get that? Let's assume for some goofy reason that these last two, we want these to be 1 and 2. So I just say here equals 1. Now this is 1, this is 2, this is 3, this is 4. Make sense? All right. But for some reason, don't ask me why, we want these two. We want oak to be 1, we want maple to be 2, but we want apple to be 43. And we want cherry to be 44. Okay? So I come in here and I do this. Now oak is 1, maple is 2, apple is 43, and cherry is 44. So it always adds 1 as far as the value onto the next one, unless, I mean, if I wanted to, I could make this equals 66. I can do that. It's totally legal to do that. You can renumber any way you want. You cannot do this. Why can't I do this? It's going to be, no matter what you say, it's even more fundamental than that. Yeah, you'll get an error, but why? Yeah, they're the same, because the way the system works with it, the word oak and maple are what you use. The computer cares only about the underlying value. All right, and it's saying I've now got 2 different things that are both equal to 1, and the system says when you ask for it, it doesn't know which one to give you. So you cannot do that. All right, so an enum they say is a specialized class. Okay, I can live with that. There's different things you can do with enums, and don't worry about it, because we're not going to really do much of anything with enumerations in here. All right. What they can do is they can end up making your especially if you use a switch statement, it can make it much easier to work with. Let's say that I had an enumeration, okay, and I created, and I called it programs, okay, and I said application web development equal 1, all right, Cisco equal 2, etc. Then if I put that in the code, it's much easier than having to worry about number 1 being AWD to be able to say application web development. All right. All right. Now I'm going to say something here. I'm going to date myself, so I'm going to give you something, and you may or may not have ever heard of this. Okay. I don't know if they still do this today or not. Probably not. Back when I was your age, in fact, I was younger than you, I started at the University of Wisconsin-Milwaukee at age 17. All right. When I was 18, I moved out of the house. All right, why am I telling you this? Because I was responsible for getting my own butt out of bed and getting to school all the time. All right, I had 3 jobs at the time. I was working 80 hours a week and going to school full time. All right, and it was bad. I got mono, lost about 45 pounds, etc. All right, but the point is, I would go and I would drive down to the University of Wisconsin-Milwaukee. And hopefully you can imagine this. They didn't have a lot of parking lots. You parked on the street, okay? If you were lucky, you found a 4-hour spot. If you were unlucky, you found a 1-hour spot. If you had a 2-hour class and you only had a 1-hour spot, then you prayed that the instructor would give you a break so you get out and move your car, okay? So what would happen typically is they called them meter maids, and I don't want to be politically correct, meter people. They would go around, and it almost looked like a bicycle with a top on it. It was a real little, like a golf cart almost. They would come around, and they would put a little white chalk mark under your tire, okay? Then they would come around again an hour later, and if that chalk mark was still there, they knew if they came around maybe an hour and 5 minutes later, you parked too long, so you got a ticket. Does that make sense? All right, so what does that have to do with anything? If I'm going and do this in a program, so if I come in here and I say string S1 equal Bob, all right, then later, that was bad. Later on in my program, I come in and I say S1 equals Robert. All right, when I first did this, when I first came in here and said S1 equal Bob, when I first did it, the system goes and someplace in memory, and I don't know where, and I don't care where, but if this is memory, if it's like a bunch of little mailboxes, literally, there are billions of these. So when I do that string S1 equal Bob, it puts Bob in here, let's say, at location 1000, all right? So now later in my program, I say S1 equal Robert. It doesn't put it there. It puts it someplace else. Maybe in location 8888. That make sense? But now, this has still got Bob in it. Nobody needs it anymore. So what the system does is it marks this location, and it says 3 bytes starting at location 1000 are no longer being used. All right? And there's a program that runs under the operating system that's called the garbage collector. It's kind of like the meter maid. So the garbage collector looks and it says, okay, no one's referring to this. So when it comes back around and it checks again, it's like the meter person checking to see if that underline is still there. So it checks it once and it flags it, then it checks it again, and if it's still not being used, it gets rid of it. So that's collecting the garbage. All right? You can even ask the system to call the garbage collector for you. You say system.gc. So you can do that. But the garbage collection runs under the operating system, and it runs at a really, really low priority. So what that does is it says, hey, operating system, whenever you're free, please go and do garbage collection. Okay? But it's like, if my garbage comes on Tuesday and it's Wednesday, I can stand out at the end of my driveway and start screaming for the garbage man, but they're not going to come till the next week. All right? In just the same way, I can do this, but the system won't actually call the garbage collector until it has some free time. Then it will do it. All right? Long story, but that pretty much is everything that they do, that they explain on this slide right here. And it's all done under what's called the JVM. Kind of important concept if you look right here. This is the kind of thing you could easily be asked at an interview. What is the JVM? It's the Java Virtual Machine. Basically, for lack of better words, it controls everything Java. All right? When we were working in C# and ASP.NET, they don't have a Java virtual machine because it wasn't Java. They use something called the CLR, or the Common Language Runtime. But it says here, the Java virtual machine has a process that runs in the background to reclaim memory. So it's under the operating system, and what it does is it reclaims memory. Okay? Anybody, do people in here, and I know Brady's got some hardware background, I don't know about the rest of you. Have you ever heard of the concept of a fragmented disk? And if you haven't, it's like, think about it this way. Okay, think of memory as being this really, really big circular thing. It doesn't have to be. It can be this way too. It doesn't matter. But I keep saving stuff in memory. Okay, I'm saving and I'm saving and I'm saving and I'm saving. Pretty soon, I don't have a lot of contiguous memory locations. I've got a bunch of stuff, and then I got a few bytes here and a few bytes here. Now I want to save something real big. The system takes longer because it's got to save a little bit over here, and then a little bit over here, and then a little bit over here. So if you run what's called like a defrag utility, what that does is it attempts to take all those memory locations and put them all together on the disk. That's kind of what the garbage collector is doing. It's trying to reclaim any memory that's not being used, so nothing is pointing to it anymore, and make it available to the program. All right? Okay. We talked a little bit before, and I'm going to say something that's actually not in the slides here, just so you hear it. We talked before, and am I right in assuming that all of you now at least have an idea of what a constructor is? Is that a fair assumption? If you've got something that's called a constructor, what would you think you would call something that would be the opposite of a constructor? What? A destructor. Java actually has something that's called a destructor. You do it just like a constructor, but what you put at the beginning, everybody know what a tilde is? A thing that looks like this, okay? If you put that at the beginning, that's a destructor. This is the problem. I just want you to hear this. The problem is, you know what a constructor is called. A constructor is called when you create a new object. But when the object goes away, you have no guarantee that the destructor is called then. It's telling the system, hey, this is now null. When you get some time, please get rid of the object. Okay? So destructors are hardly ever used. But what you can call in lieu of a destructor is a finalize method. And as it says, it will run just prior to the garbage collector. Why would you do that? You could call that if you knew you maybe had some kind of a network connection that you wanted to sever, or you had a database that you wanted to make sure was closed, or whatever. So a lot of the stuff that's done in here would be done for housekeeping reasons. All right? All right, and the last thing that's in there is they talk about CRC, class responsibility and collaboration. And this is the idea. I've got a class called stock. These are the methods that it has. Okay? These are the methods or classes it has to be able to communicate with. So stock will have a no stock to purchase method that has to communicate with a stock class, a no number of shares method that communicates with no one, a calculate cost of purchase that goes with a stock class, etc. All that this is, people literally will oftentimes do this on, maybe it looks like one, maybe it doesn't. They will oftentimes do these on actual index cards. And it shows how different classes are going to communicate with one another. That's all it's for. There's software that you can get that will do it also. All right? So we're going to take a break, but before we do, again, tomorrow we will go over this chapter right here. Not going to do it now. So it's 1:27. We're going to take a healthy break. At 1:45, start up. In fact, why don't we do this first? If you don't have this, please look up on your screen. And I'm not sure, again, if you've got a folder called Java or one called payroll or something else. I've got a folder called payroll. All right? And I'm going to take this array fun thing that's in there right now, and I'm going to call that, I'm going to leave it the way it is. All right, I'm going to come in there and I'm going to create a new folder where I've got all my other ones that I'm going to call array fun 2, because I already have an array fun. You can create an array fun 2. You can call it array fun. It really and truly does not matter. All right? But I want to get that path because I'm going to come in here. I'm going to start up IntelliJ IDEA. I closed my project. That was the birthday one. Actually, that was yours, Amin. That was when I created it yesterday. So I'm going to create a new project, just like we've been. There's nothing new here. Give it the path where my array fun, or in my case, array fun 2 is. All right. Come in here, right mouse click on my source, new Java class, edu.rankin.jpscott.array fun. All right. So if you've done that, and if you have this, that's what I want you to be. Again, you'll have your own package name, of course. Take a break. Come back, please, in 16 minutes. And the class name can be the same. Yeah. Did everyone who wanted to upgrade their test, did you all email me the upgrades? Because I'm looking here and I've got one from Amin, one from Ivy, one from Ethan. So I don't have them from anybody else. All right. All right.